Welcome to the early history of chemistry. So, long time ago in ancient Greece, roughly 400 BC, the Greeks proposed that all matter is composed of four fundamental substances, four elements, as it were: fire, earth, water, and air. So something like this, right? So they figured that if you took, say, a piece of pottery, well, the clay that the pottery was made out of was mostly earth, had a little bit of water in it. Well, then you fired it, you shaped it, and you put it in the kiln, you fire it, and it gains some fire, and now some of the water maybe was driven out, and now your piece of pottery is made of those. There may be a little bit of air, of wind involved there. But they didn't really get too much farther than that until Democritus comes along, and he proposes the existence of atoms, but he really has no way of testing his hypothesis experimentally. He's just supposing that, well, if you look at a wall is made up of bricks, right? And just like a wall is made out of bricks, he figured that if you look at some other substances, say aluminum foil, if we take a sheet of aluminum foil and we cut it in half, well, now our sheet is half the size. And we cut it in half again, and cut it in half again, and cut it in half again. The other Greeks of the time were of the opinion that you could keep cutting and cutting and cutting, and your object, your aluminum, just got smaller and smaller and smaller. Now, Democritus was the first one to say, no, I don't think that's true. I think that at some point you get down to where you have just two atoms left, and when you cut it in half, now you've got one atom, and now you can't cut that atom in half anymore. Now, he thought that you just couldn't cut it in half anymore. But now we know that that's not true. We can split an atom apart, but when we split the atom apart, we no longer have the same sort of stuff that we did before. If we split an atom apart now, of course, we know that we get out protons, neutrons, and electrons, and we can split some of those apart. We can split the protons and neutrons apart to get quarks out. But the protons, neutrons, and electrons don't act the same way as that aluminum atom did. But before that, before we start splitting the atom, if we go from 100 atoms down to 50 atoms, the atoms in there still act the same way. They have all the same chemical and physical properties. We just have a smaller chunk of aluminum. Okay? So Democritus is the first one to propose this idea that there are atoms. There is a smallest unit of matter that you can't get below. Now, of course, we know that you can get a little bit below atoms, but the properties are changing. You no longer have the same sort of stuff. So, after Democritus and the Greeks, for then about 2,000 years, alchemy dominates the study of substances. Now, alchemy is sort of a pseudoscience sort of thing. So many of the alchemists were attempting to turn cheap metals like lead into expensive metals like gold. Now, some of them actually went about it in a fairly systematic, scientific way, and some of them were just charlatans trying to make a quick buck. Now, we know that we can't, at least as of now, we can't change lead into gold. It may be possible using a particle accelerator, but it's certainly not going to be worth the energy that you have to put into it, so it's not going to be a way of making money. So some of the alchemists also were able to discover some elements, and they also learned how to make some compounds. So even though there isn't a whole lot of development going on, we are able to see, we're able to refine some compounds, we're able to discover some elements. We're starting to see there are more than just four elements, there's more than just the four elements of earth, air, fire, and water. And so we need to be able to move past this. So in 1661, Robert Boyle sort of becomes the father of quantitative chemistry and physics. So he's suggesting that an element is any substance which cannot be broken down into two or more simpler substances. And Boyle does some other experiments that we'll talk about in some later videos. But around 1700, then, Georg Stahl suggests that this stuff called phlogiston, he called it phlogiston, flows out of burning material. Now, you know, of course, that when we burn something, we get some smoke out, and he noticed that, well, we get some smoke out, and he was calling this this sort of substance phlogiston. Right? And he noticed that combustion stopped when the air becomes saturated with phlogiston. Right? And so he thought that when you burned something, this phlogiston stuff comes out, and if you enclose your fire in some sealed container, that the phlogiston eventually saturates the air, and now you can't get any more phlogiston out of your material, and the fire stops. Right? Even though you may have more material to burn. Now, of course, we know that, well, we don't get phlogiston out. The fire consumes oxygen. It doesn't produce phlogiston. So, even though he's wrong about his idea of phlogiston, he makes some strides towards recognizing that if you seal a fire, that it eventually goes out. And he's making an attempt to explain why. Now, this is a theory. It's an incorrect theory. We now have evidence to prove that this theory is incorrect, but it was a good attempt for the time. So, Joseph Priestley then comes along and he discovers oxygen gas, and because it readily supports combustion, it was called dephlogisticated air. So basically, at the time, they originally thought, well, oxygen is this stuff that has very little phlogiston in it, so we can get lots of phlogiston to come out into it. Now, of course, again, we know that oxygen is what's necessary to support a fire. So if we don't have any oxygen around, then the fire dies. So that was the early history of chemistry.